Guys, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, I'm going to look at a wide range of characteristics for various members of the group 6 elements, and particularly we shall look at the characteristics of oxygen, sulfur, and of course these particular members of selenium and tellurium, which we had mentioned in our last discussion. Now, they basically excluded polonium due to its specific characteristics of being an radioactive element, and that one, of course, as I had mentioned, limited some of its specific application. Now, oxygen is the most abundant element in this specific group, and of course, in terms of its availability in the Earth's crust, it's going to be forming 45.5%. So that's in terms of abundancy by composition. Composition by mass in the Earth's crust, it's going to form 45.5%, and of course it's going to form approximately 90% by mass of the seawater. And then we are going to see that apart from this one, it's going to be forming 23.15% by mass, or 21.04% by volume given as such. So this in terms of abundancy, we're going to see this specific relative figures of its particular availability in terms of percentage. So this is going to be 23.15% by mass, and this is going to form a 21.04% by volume in terms of its abundance. Now, in this particular case, we are going to see that apart from it being available in these particular various areas in the Earth's crust, in the sea, and the percentage by mass and volume, we are going to see that the principal source of oxygen is going to be atmospheric air, and this is going to be obtained through what we refer to as a fractional distillation, whereby this specific composition of air is going to be condensed, and they are going to be distilled at their specific temperatures, which are going to be their boiling points. Now, in this case, if I compare between the air composition of nitrogen and oxygen, and perhaps this specific component of argon and other gases, we're going to see that these are going to display various range of temperatures for their boiling points. And for nitrogen, this is going to be 77.4 kelvins. For oxygen, this is going to be 90.2 kelvins. And then we're going to see the other remaining is going to be 87.5 Kelvin in that particular case. So due to their differences in temperature, therefore, it's going to be convenient for us to be using this fractional distillation procedure in order to obtain it from atmospheric air given as such. So there are various ranges of applications which we are going to see for oxygen, and this is going to be ranging from the medical field and the treatment of perhaps some of the compounds which we are going to see in terms of reducing them or oxidizing them, forming their oxide forms in their industrial processes. And also we're going to see that it's also going to be exploited heavily in the fabrication and welding industry. So if we can mention just a few of them. For mention the concept of being used in hospitals, in breathing devices, and then we're going to see that it can also be used in fabrication and welding. So acetic flames are going to be part of this specific application of oxygen. So we're going to have fabrication and welding a big part of the uses of this particular component of or element of group 6 elements. And also it's going to be used in water treatment, and then we shall have it being used in confined spaces or spaces where there is limited air, especially in submarines and the spacecrafts. And then we are going to have this one. So we had mentioned this specific aspect of being used in this particular environment, whereby we say that this is going to be given in this particular form, where carbon dioxide is going to be reacted with that specific oxide to provide a carbonate plus oxygen, and therefore this is going to be used in those specific environments where there is a limited supply of air. Now those are some of the uses of oxygen which we are going to come across. And of course, apart from those ones, perhaps we just mention the rest in case we come across them in our various discussions. Now, in this case, we shall look at another member of this particular group, which basically is the member of sulfur. Now, we had said that sulfur basically is going to be a yellow solid, which is going to be found in this particular group of members. And it's going to be the 16th most abundant element by mass being given as, so I can just give this one in summary form. So 16th most abundant by mass, and this is going to form around 6.003 or 6.038%, so by mass in terms of abundancy. So that's the element of sulfur. And in terms of occurrence, we are going to see that sulfur is going to be occurring in terms of its, of course, mineral sulfides. And we can give an example of this one. For instance, we're going to have this one, mineral sulfide, or the hydrogen sulfide, which we had mentioned in our first case for the most important, of course, compound formed by sulfur. So this is going to be in terms of natural gas, which is one of the sources of this sulfur which we are going to come across. But on the industrial scale, we are going to use one of the methods referred to as the Frost process. And the Frost process is going to be used in manufacture of a sulfur from its sulfur rocks, or the sulfur ore found deep under the ground. So I'm going to have just a rough illustration of this specific process so that we discuss it in some summary form, and that will form a final bit of a discussion on the concept of a sulfur. So the first process is going to consist of a specific arrangement of concentric pipes, which are going to be, of course, given in this specific format. So these are going to be pipes dug into the ground to the level of this specific, of course, ore that contains sulfur. Now we're going to give this one in terms of a sulfur rock given as such. So this is going to be our source of sulfur, which is going to be found deep underground, even in terms of a sulfur rock. Now in this particular case, we're going to see that this particular section, we're going to have a superheated. So this is going to be a superheated water, which is going to go in using this specific inlet at this particular point. And this is going to, of course, come into contact with this particular ore or fragments of the rocks containing sulfur at this specific part of the ground. We're going to see that one of the characteristics being exploited in this particular fresh process is that sulfur has got a low melting point. And therefore, upon interaction with this specific sulfur, this is going to be melting this particular sulfur. And of course, this is going to be mixing up with the specific components of sulfur being given at this specific point in the sulfur rock. Now, this specific middle point, there's going to be a compressed air that is pumped. So we shall have compressed air at 20 or at 20 to 25 atmospheres being pumped at this middle section. Now, this is going to force the mixture of course, the sulfur and of course the components of the sulfur rock, which are going to be found at this specific point. And now this is going to be forced out due to the pressure through this specific section, and they're going to come out at that particular point in terms of a liquid sulfur. So this is going to be a summary of the fresh process which I have mentioned, whereby compressed air at 25 atmospheres is going to be pumped down this particular inner pipe towards this specific point for the sulfur rock, and this is going to force sulfur with water mixed up in this specific superheated water to go up the remaining pipe which I have shown at this specific point, and that's going to be given out in terms of sulfur. Now, one of the shortcomings of this particular process is that going to be emitting some sulfur from the industrial operations, and this is going to be creating an environmental concern, which basically is going to show that this particular process is going to find, of course, some of the limitations in terms of its application in order to obtain sulfur. And therefore, due to environmental concerns, we are going to see some of the processes that are going to be used in trying to, of course, get or obtain sulfur from its various sources. So that's going to form our final bit of the discussion on the concept of oxygen and sulfur. Now, in our next discussion, we're going to look at selenium and technetium, which are going to form our final bit of our discussion on this specific group 6 element. So that is it for now, guys. Bye, God bless you. Catch us in our next video.